is section 3.1, part B. We now turn to look at what happens when the exponents are allowed to be negative numbers or integers. Let's start with a couple of examples. As I look at the problem a squared divided by a to the fifth, I want to think about it two different ways. If I think about this using the rules of exponents that we just developed, I would subtract my exponents. So a to the 2 minus 5, or a to the negative third. Now what happens if I write this out as a squared, meaning a times a, and a to the fifth, meaning a multiplied by itself 5 times, and I say a divided by a is 1, and again, a divided by a is 1. What I end up with now is 1 on the top and 3 factors of a, or a to the third power on the bottom. Since I didn't do anything wrong in either of these simplifications, it must be true that a to the negative third and 1 over a to the third are really the same thing. This brings us to our first rule for negative exponents, which is that a to the negative n power is 1 over a to the n. All right, we need one more negative exponent rule before we start to practice, and I'm going to get it from the second example. Looking at this, my numerator is 1, and one way to simplify the denominator would again be to subtract the exponents. So I would have a to the 3 minus 7, or a to the negative fourth on the bottom. Another way to simplify this expression would be to use the fact that dividing is the same as multiplying by the reciprocal. So I have 1 on the top divided by a cubed over a to the 7th. Or I could change that to 1 times the reciprocal a to the 7th over a to the 3rd. That would be 1 times, and if I subtract those exponents, 7 minus 3 is 4. And of course, 1 times anything is just that thing, so that's a to the 4th. Again, notice what happened. I didn't do anything wrong either time, and yet I got 2 different looking answers. That must mean that those are really the same. And that leads me to my second rule for negative exponents. 1 over a to the negative n is just equal to a to the positive n. Notice what really happened in both of these. If I have a negative exponent, moving it across the fraction bar makes it positive. In fact, in general, anytime you have a factor with a negative exponent, or any exponent for that matter, if you move it across the fraction bar, what happens is the sign of the exponent changes. So moving a factor across the fraction bar in either direction changes the sign of the exponent. We'll use that to help us simplifying our exponential expressions. And all of our expressions will be considered simplified if these 3 criteria are satisfied. All parentheses are removed, factors with like bases are combined, and then here's a new one. All bases must have positive exponents. If they don't, we'll use these rules to move our factor across the fraction bar and change the negative exponent to a positive one. All right, let's look at a few examples. Starting with just some numerical examples. I have 8 to the negative second. That would be the same as 1 over 8 to the second. Notice when I move it to the bottom, the sign on the exponent changes to positive. And of course, since 8 squared is 64, that's 1/64. The calculator does know negative exponents. If I type 8 to the negative second in my calculator, it gives me a decimal value. Sorry, you can't see that very well. Let me try that again. Find a good spot here. There we go. 8 to the negative second gives me a decimal value. And if I just go into my math menu and change that to a fraction, there is that 1/64. All right, let's do another one, and again, I'll just check it with the calculator. I have negative exponents on both the numerator and denominator, so I'm going to move them both across the fraction bar to make them positive. 2 to the fourth will move to the top, and 3 to the third will move to the bottom. 2 to the fourth, that's 16, and 3 to the third is 27. So I should get 16/27. Let's try it out. 3 to the negative third divided by 2 to the negative fourth, and there's a decimal value. If I change that to a fraction, there's my 16/27. All right, let's go ahead and continue with some more examples. And we're now going to go ahead and have some variables in our examples. And I want to start by taking a look and comparing numbers 3 and 4. 5x to the negative 2 with and without parentheses. Without the parentheses, the negative 2, the negative exponent, only applies to the x. So in order to turn that into a positive exponent, I would leave the 5 on top, right where it is, but I would move the factor x squared across the fraction bar. And so I'd have a 5 over x squared for my simplified form. Again, we consider it simplified because there are no longer negative exponents in the expression. Number 4, the entire 5x is in parentheses, all raised to the negative 2 power. So what I could do is take that entire 5x to the second power and move it across the fraction bar. That's just going to leave a 1 on the top. And I'd end up with 1 over 5 squared is 25, and x squared is still x squared, for a simplified form of 1 over 25x squared. Just a comment, I could have done this one differently. I could have applied my exponent to both factors inside the parentheses first, and made that 5 to the negative 2, x to the negative 2. In which case, with both of them having negative exponents, they both get moved across the fraction bar to make the exponents positive. And notice, once again, I'm going to get 1 over 25 x squared. So you can go ahead and apply the exponent first, or you can move it to the denominator first. You'll get the same answer either way. Continuing with this sort of watch out for parentheses theme, in numbers 5 and 6, once again, we have similar looking expressions, but one has parentheses and the other one doesn't. Same idea. In number 5, the negative 2 only applies to the x. So I have 5 plus, and I'll change x to the negative 2 into 1 over x squared. At this stage of the game, that's all we're going to do with that. We haven't really talked about adding algebraic fractions yet. We'll do that later this semester. In number 6, the 5 plus x is all raised to the negative second power. So the entire 5 plus x squared gets moved to the denominator with just a 1 on top. I could leave that just like that. Or, if I did want to multiply out the denominator, remember this is really a FOIL or distributive law situation. I could write that as 1 over 25 plus 5x and 5x are 10x plus x squared. Either of these are really acceptable answers. Could we have done this another way? Could we, kind of like we did up here, have applied this exponent into the parentheses first? I hope you're thinking, no, that shouldn't work right now, because it doesn't. Remember, exponents cannot be distributed across addition or subtraction. Therefore, I cannot do this problem any other way. I must move the 5 plus x squared into the denominator first, and then if I want to multiply it out, I can at that point. Okay, a few more examples. We've got some combinations of different rules here in 7, 8, and 9. In number 7, I'm going to go ahead and use the strategy of saying this is multiplication, so I can apply my exponent to both factors separately. I would have 4 to the negative third. And on the x, remember a power raised to another power, we're going to multiply our exponents. So that's going to be a 15th power. 4 to the negative third, I don't want to leave that negative exponent in my answer. So I'm going to move just that factor into the denominator, making it 4 to the third. And this time, 4 to the third, that's just a number. 4 times 4 times 4 is 64. All right, in number 8, I'm going to apply a similar strategy to both the numerator and the denominator as my first step. So this negative 3 actually gets applied to all 3 factors in the numerator. 2 to the negative third, x to the positive 12th, and then y to the negative third. Same idea in the denominator. That exponent of 2 gets applied 3 times. 4 squared, x to the 2 times 2, or 4, and y to the negative 10th. All right, in my next step, I'm going to move everything that has a negative exponent across the fraction bar. So I'm going to move that factor and those 2 factors. For starters, I'm actually going to go ahead and say the x to the 12th, that can stay right where it's at. So can the 4 squared and the x to the 4th. Those are not moving. All right. That 2 to the negative third, I'll move that to the bottom. Make it 2 to the third. And again, y to the negative third, let's move that to the bottom and make it y to the third. Y to the negative 10th from the denominator gets moved to the top and becomes y to the positive 10th. All right, I'm going to kind of just neaten this up a little bit. For starters, let's see, over here. The numerator, I'm just going to leave the way it is for the moment. X to the 12th, y to the 10th. And in the denominator, notice I've got 2 numerical multipliers. 4 squared would be 16, and 2 to the third would be 8. I'll multiply those together in my next step. Then I've got an x to the 4th and a y to the 3rd. To finish this up, 16 times 8, I think that's 128. And then, since I'm dividing, I'll subtract exponents. 12 minus 4 is going to give me x to the 8th. And 10 minus 3 is going to give me y to the 7th. And I probably have a little more fraction bar there that I need. But that would be my simplified answer. All right, one last example here. In number 9, we have a whole bunch of things multiplied and divided. And I'm going to start by noticing there are no exponents outside these parentheses. So I can actually just start multiplying and dividing things together. Let's do that. I'm going to begin by doing the 16 times the 25. That's 400. And the 15 times the 8. Is that 120 again? Yes. All right. In my numerator, I've got a to the negative 2nd and a to the 4th. So if I go ahead and add those exponents, I'll get a squared on top. As far as the b's, I actually have b to the 1st, and I'm going to combine that with the b to the negative 5th. Again, adding exponents gives me b to the negative 4th. Same idea in the denominator. For the a's, I would add a 5 and a negative 7. So a to the negative 2. And then for the b's, I would add a negative 1 and a negative 2, giving me b to the negative 3rd. Okay, I'm just going to use a nice shortcut here and say, reducing this 400 over 120, if I just take my calculator and take 400 divided by 120 and change my answer to a fraction, there's a nice little shortcut for getting the lowest terms quickly, 10 over 3. All right, next, you can do as you like with this. Last time I moved all of my negative exponents to make them positive before I started combining things, and that actually is my preferred method. If you would rather, you certainly can subtract the exponents right now. I'm going to go back to what I tend to like to do. I make less mistakes if I work with positive numbers. So I'm going to say all three of those factors with the negative exponents, I'm going to move them across the fraction bar to give me positive exponents. A squared is still going to be on the top. But then this b to the 4th is going to move to the bottom. That a squared will move to the top. And that b cubed will move to the top. All right. So I've got 10 over 3. A squared and a squared. I'm going to go ahead and add up those exponents to make that an a to the 4th. And then look at what happens with the b's this time. If you were to subtract those exponents, 3 minus 4, you'd get b to the negative 1. But since we don't really want a negative exponent, we'd want to put that into the denominator as b to the 1st. In practice, what I usually do is I just subtract the numbers in the order that gives me a positive answer. 4 minus 3 gives me b to the 1st. And since there were more b's in the bottom, the b to the 1st ends up on the bottom. Again, there's multiple different ways you can think about these. Just trying to sort of lead you through my own personal thinking strategy here. All right, that concludes Section B.